Have you ever been on an airplane and stuck at the middle of a lightning storm that is getting worse and worse? If yes, this question might have crossed your mind that what happens if something goes wrong with the airplane due to the lightning storm's mid-air? Well, first of all, you shouldn't worry at all as commercial airplanes are designed, tested, and certified to withstand lightning strikes, which are relatively common and pose a potential risk to the safety of the aircraft and its passengers, and the crew is trained to handle the effects of a lightning strike should one occur. To protect against lightning strikes, a combination of design features and electrical systems are used, and in the vast majority of cases, lightning strikes to airplanes result in no damage or harm to the passengers and crew. Welcome to High Technology. Join us today at High Technology channel as we are going to check what security measures have already been implemented on commercial airplanes to protect both passengers and the plane midair against lightning storm. If you also enjoyed this content, please don't forget to like and hit the subscribe button and the notification bell so you don't miss our next videos. Flying on a commercial airplane during a lightning storm can be safe as long as the aircraft is equipped with a robust lightning protection system. These systems are designed to safely dissipate the electrical energy from a lightning strike and prevent damage to the aircraft. That being said, it is still recommended to avoid flying through thunderstorms as much as possible. If a storm cannot be avoided, the aircraft is flown through the area with the least amount of lightning activity. In general, the risk of a lightning strike causing a serious accident is very low, and commercial air travel remains one of the safest forms of transportation. Commercial airplanes are protected from lightning strikes using the following methods. Conductive materials. The aircraft skin is made of conductive materials that dissipate the electrical energy from the lightning strike evenly across the surface of the aircraft, or better to say, the exterior of the aircraft is made of conductive materials such as aluminum, which helps distribute the electrical energy from a lightning strike evenly across the surface of the aircraft. This helps to prevent localized overheating, which can cause structural damage, and reduce the risk of electrical arcing, which can damage sensitive electrical systems and cause ignition of fuel or other flammable materials. Grounding. The aircraft is connected to the ground through a static discharge wick, which helps to dissipate electrical energy into the ground. Bonding. All metal parts on the aircraft are electrically bonded together to form a continuous conductive path, which helps to prevent arcing and damage from lightning strikes. Surge suppressors. Electronic equipment on the aircraft is protected by surge suppressors, which prevent electrical damage from lightning strikes. The electrical systems on board the aircraft are designed to withstand high voltage transients and surges that may be associated with a lightning strike. For example, electrical cables are shielded to prevent electrical arcing, and electrical components are protected by transient voltage suppressors that help prevent damage from voltage surges. In the event of a lightning strike, any electrical currents that enter the aircraft are safely directed to the ground via bonding wires and other conductive paths, which helps to prevent damage to the aircraft and its systems. Avoidance. Pilots are trained to avoid flying in thunderstorms as much as possible. If a storm cannot be avoided, the aircraft is flown through the area with the least amount of lightning activity. Commercial airplanes are also equipped with lightning detection systems that can alert the crew to the presence of a nearby lightning strike. This information can be used to adjust a flight path or altitude to reduce the risk of a lightning strike, or to prepare the aircraft and its systems for a possible strike. The crew of a commercial airplane is also trained to recognize the signs of a lightning strike and to respond appropriately. This may include shutting down certain electrical systems and monitoring the aircraft for any signs of damage. In the unlikely event of a lightning strike, the crew is equipped with the tools and procedures necessary to respond safely and effectively. The concept of lightning protection for commercial airplanes has been around since the earliest days of air travel. As air travel became more widespread, the need for effective lightning protection became increasingly important, and standards for lightning protection have been developed and refined over time by organizations such as the Federal Aviation Administration, FAA, and the International Civil Aviation Organization (ICAO). The use of lightning protection systems on commercial airplanes became more widespread in the mid-20th century as the aviation industry continued to grow and the technology for lightning protection systems improved. The current standards for lightning protection on commercial airplanes have been established through the collaboration of aviation experts, government agencies, and aircraft manufacturers. It is difficult to determine which specific aircraft has the highest lightning protection, as the level of protection can vary depending on the specific design and configuration of the aircraft. However, modern commercial aircraft are generally equipped with robust lightning protection systems that meet industry standards set by organizations such as the Federal Aviation Administration and the International Civil Aviation Organization. Some factors that can affect the level of lightning protection for an aircraft include the materials used for the aircraft scan, the design of the grounding and bonding systems, and the use of surge suppressors for electronic equipment. In general, newer aircraft models tend to have more advanced lightning protection systems than older models due to advancements in technology and improvements in our understanding of lightning and its effects on aircraft. Lightning strikes to commercial airplanes do occur, although they are relatively rare and typically do not result in significant damage or accidents. In most cases, lightning strikes to airplanes are absorbed by the lightning protection systems, which are designed to safely dissipate the electrical energy from the lightning strike and prevent damage to the aircraft. However, there have been instances in the past where lightning strikes have caused problems for commercial airplanes. For example, there have been instances of lightning strikes causing temporary malfunctions of electronic equipment on board the aircraft, and in rare cases, lightning strikes have caused structural damage to the aircraft. It is important to note that despite the occasional lightning strike, commercial air travel remains one of the safest forms of transportation, and the risk of a lightning strike causing a serious accident is very low. Airlines and aircraft manufacturers continue to invest in research and development to improve the lightning protection systems on commercial airplanes and to minimize the risk of lightning strikes causing problems for passengers and crew. In summary, commercial airplanes are protected from lightning strikes through a combination of design features and electrical systems that help to distribute the energy from a lightning strike evenly across the surface of the aircraft, withstand high-voltage transients and surges, detect lightning strikes, and respond appropriately to a lightning strike. These measures help to reduce the risk of damage to the aircraft and its systems, and to ensure the safety of the passengers and crew. Please let us know if you have ever experienced a lightning storm at the middle of sky on an airplane. If you also enjoyed this content, please don't forget to like and hit the subscribe button and the notification bell so you don't miss our next videos.